All right, so good evening, everyone. Right, so just this exercise is a check for me to see whether you've understood all that we did so far. And once you can do this, I will be moving on. Here's what we're doing. You are taking dilute and concentrated HCl, dilute concentrated HCl, and you will let me know what we're going to get. Right? So let's do, and of course, it will be inert electrodes. Always assume inert electrodes unless we tell you otherwise. So let's start with dilute HCl, and of course, graphite or inert, which is inert electrodes. All right? So we're going. Okay, if you were asked to draw an electrolytic cell, let's draw it. Let's put in the battery. We put in the battery, the electrodes, the electrolyte in a beaker, maybe, right? We can call it, it's actually called an electrolytic tank, right? So these are my electrodes. The one that is connected to the positive terminal of the battery is the anode, reminding you of these things, which is a positive, right? This is the cathode on this side that is connected to the negative terminal of the battery. Short, negative, tall, positive, right? And this is my solution, my dilute HCl solution. And of course, dilute means water is present. In fact, dilute and concentrated means water is present. So let's identify all the ions. So the ions from the HCl will be H plus and Cl minus, of course, you know that. The ions from the water, which is only weakly ionized though, but will be H plus and OH minus. Is this okay, everyone? Right. Are these the ions that will be present in dilute HCl? You'll agree? All right. So we have to figure out at the cathode what's going to happen. You will recall that the cathode is cations migrate to the cathode. I'm helping you remember these things. Cations migrate to the cathode, but only one will be discharged at a time, will be migrating towards the cathode, right? Where reduction takes place, right? Reduction takes place at the cathode. Right. So which are the ions that would migrate towards the cathode, guys? Which is the only positive ions in solution? Could you tell me? Do you agree with me? There will be no competition at the cathode because it's all H plus. How many of you see that? At the cathode, there is no competition. Why? Yes, it's a both H plus from the HCl and the water. So what will happen at the cathode? We'll have reduction, which is a gain of electrons. You will write it like this. Always put your state symbols, but you will form what will we see at the cathode? A question could ask you, state the observation at the cathode. What will you observe? An observation is what you see with your eyes. What will you see? Colorless, bubbles, on cathode. Do you guys agree with me? Yes, y'all. Let's do the anode now. Now the anode, we see anions are attracted to the anode, which is a positive electrode, and ions migrate to the anode, and oxidation takes place here. Okay, so at the anode, these two of them would move towards the anode, but only one could be discharged at a time. So it's either chloride or hydroxide. Could you tell me which, based on all that I did with you last week, between chloride and hydroxide, which will be discharged first? Look at your series. Look at the series for the anions. Hydroxide is less stable. Hydroxide is lower down in the series. It is less stable, and also is it higher in concentration. So yes, we will get hydroxide here, some of you are saying. So this is what happens at the anode. You have to learn this equation. R4E. And again, the observation here will also be a colorless gas at, or colorless bubbles around or on the anode. Do you guys agree here? So they can ask you for the equation at the cathode and the anode. Not can, but will, if it's in a question. They can ask you about the observation, so I guess you could handle up that. Next, they can ask you this: what is the ratio of gases produced? Let's see if we can do this. Can I take out this page? Pen, can I take off here? Lead, can I take off here? All right. So next, ratio of gases formed. And you can write it like this, so that that examiner reading your work will be clear about what you meaning, right? Cathode, anode. So at the cathode, I'm getting H2. At the anode, I'm getting O2. And the ratio of the gases will be 2 to 1. Do you guys understand? And one more time. H2 needs 2 electrons to be discharged. And O2 needs 4 electrons. You're not to get confused with this, to be discharged. Right. So think of electrons like electricity. Which one requires more electricity to be discharged? The hydrogen or the oxygen? Which one needs more electricity? Hydrogen or oxygen? Right, oxygen. So will the oxygen will take longer to come out because it's waiting for the amount of electricity to flow. Is that right? Can I think about it like that? Right, so that's why I get twice the volume of gases, twice the volume of hydrogen to oxygen. Are you satisfied with this? Okay, next they're going to ask you this if the question is difficult, because students often would not get out this part. What happens to the electrolyte. So when we do electrolysis, we had these ions in there, H plus, Cl minus, H plus here, and OH minus. What happens to the electrolyte? Which ions are we taking out? You're taking out H, be it from the electrolyte, well, right? And we're taking out OH. Is this okay? So therefore, the electrolyte is becoming, tell me if you all see it, more concentrated. It's becoming richer in HCl. HCl is remaining behind. Is this okay, guys? More concentrated meaning less water in there. Are you fine with this one? So concentrated HCl. And of course, inert electrodes, not unless we specify. Okay, let's draw again. So you'll get in the habit of drawing. You put your battery. You could choose to put an ammeter if you like. If you're measuring current, you can feel free to do that. You put your electrodes, which will be made of graphite. Inert electrodes are graphite based. And of course, they are dipping into our electrolytic tank or cell, which will have our electrolyte, which is the HCl. It's concentrated. This is the negative terminal of the battery, short negative, tall positive, right? These are our electrodes, right? Of course, you know, this would be our cathode, short cathode, right? Anode. And please note, they can be on any side, right? I put my cathode on the left here, but I could have very well put it on the right. It doesn't matter. All right. So what ions do we have in here? In concentrated HCl, right? From the HCl, again, I have H plus and Cl minus. From the water, it's concentrated, yes, but water is still also present. I have H plus and OH minus. Okay, let's write the equation for the cathode. No competition at the cathode. It's all H plus. So 2H plus add 2E to form H2. Remember, reduction takes place at the cathode. It's a gain of electrons. At the anode, we have competition now. It's either Cl minus or OH minus. Which one will be discharged? So even though OH minus, even though OH minus is lower in the series, ECS is electrochemical series, the Cl minus is discharged as it is in high concentration. This outweighs the position as both are close together in the series. Do you remember this from last week? Did I say that? Did we not have this discussion already? I know OH minus is lower, but Cl is going to be discharged here. Why? Because it's higher in concentration, right? It's high in concentration, so that is outweighing the fact that OH minus is lower, right? Because they're close by in the series. They're close together. So a little extra concentration on the chloride outweighed that. Is this okay, everyone? Guys, are you okay with that? 2Cl minus, they give you Cl2 add 2E. Do you guys agree? Now tell me observations, because they could ask you that. Cathode, what are you going to get? Colorless bubbles. Cathode will be colorless bubbles. Is this being recorded, this part? Yes, it is. Colorless bubbles. Or let's check my body recorded, huh? At the cathode. And what will we see at the anode? The anode, you'll see a greenish, yellow gas or discoloration around the anode. That would be the chlorine gas, which is green-yellow. All good with this? So we're doing concentrated HCl. What do you think they're going to ask you now? What could come next? Could they ask you about the ratio of the gases? Yeah? Take this off. Taking it off, right? Let's see. What will be the ratio of the gases? Let me see what you will put in the chat. Cathode, anode. I want to be clear on what I'm saying to the examiner. Right. Cathode, anode. What will be the ratio of gases? Ratio of gas volumes will be, who says 1:1? Because look at the two of them. The two of them required 2 electrons. All good? Who agrees with the ratio, guys? Make sense? Both of them requires 2 electrons to be discharged, right? Then they could ask what happens to the electrolyte. So when we do this electrolysis and we strip, so this is H plus, Cl minus, H plus, OH minus, right? So this is all the ions present in that solution. If we remove H plus, anyone you could pick, and we remove Cl minus, what is being left behind? What happens to the electrolyte? I know you all saw that. What happens? Right, very good. It becomes, very good, more dilute as electrolysis proceeds. Well done. Proceeds. My head is be thinking one thing and the handwriting another. All good with this? Why it becomes more dilute? Because what's left behind? If I remove H plus and Cl minus, HOH remains behind. HOH is water. Sure. Electrolysis of dilute H2SO4 or water, same, because it's the same thing you get, acidified with H2SO4. So this is what we're doing. And of course, the electrodes are inert, using inert electrodes. Let's draw. No, we don't need. Okay, let me put the cathode on this side before you think it must always be on that side. So here we go. Right, so my electrolyte is the dilute H2SO4. This is my cathode. This is my anode, of course. Cathode positive. Cathode negative, sorry. Right, why? Because it's connected to the negative terminal of the battery. The anode positive, because it's connected to the positive terminal of the battery. Nice. So we have H2SO4. Let's see what ions are present in here. H plus and SO4 2 minus. And then from the water, we'll have H plus and OH minus. So at the cathode, I think you'll have seen it already. Any competition at the cathode? Do we have any competition at the cathode? It's only what at the cathode? It's only H plus at the cathode. So what we getting? And you know the observation, colorless bubbles. All good? And at the anode, what will we get? I think this one is a giveaway. What will we get at the anode? Sulfate or hydroxide? You look at your series, your electrochemical series of the anions. Is sulfate too high up in the series? Very good. Sulfate is too high up. Is sulfate too stable, everybody? Yes, so it's high up in the series. It does not want to get discharged. And plus, the hydroxide is high in concentration. Sulfate will never be discharged. 4OH minus to form 2H2O, add O2 gas. All good? Let me know if you guys are okay here. Add 4E, of course, right? Take it down. Did you write the observations? Right, colorless bubbles. Very good. Ratio of the gases. We have H2 to O2. I'll put cathode, anode. Let me hear you. What's the ratio? Is this correct? Could you tell me if that is correct or wrong? Because it's the most common mistake we have here. Very good. It's wrong. It is wrong. What will it be? Nice. 2 to 1. All good? I'll get twice the amount of hydrogen because it needs less electrons than oxygen in the same amount of time. Are you okay with this? Right. What happens to the electrolyte? I have H2SO4. From this, I get that SO4 2 minus H2O, H plus, and OH minus. What am I taking out? What is being discharged? That and that. What remains behind is becoming more more concentrated or less concentrated? Tell me. More concentrated or less? More concentrated. All agree? Or you would even get it right if you say it's becoming more acidic. Can I say that too? Now, if you don't like what I'm going to do now, you will just learn off. You have no choice but to just learn off the what it is, right? What I want to work out here is the overall reaction. If you don't like it, then just learn it off, no problem, right? But before, I always have students who always miss how that could be the overall reaction. So let me just do it, right? So I have these two equations to form H2. This is taking place at the cathode. This one is taking place at the anode. At 4E. Anode. Right. Here's what I want to do. I want to figure out what is happening overall in here. So I'm going to balance my number of electrons. So I'm going to take this first equation and multiply it by 2. So if I multiply that first equation by 2 to get 4 electrons, right? 4H plus at 4E will form 2H2 gas. Is that okay with the first equation? Yes or no? I'm writing back my second equation. Add 4. Here's what I'm going to do now. I'm going to add them up. Right? So I balance the first equation. This is second equation. I'm now going to add them up. Right? So I'm going to add up everything on the right hand side. So these go on the left. Right? And these, of course, will be everything on the left. All agree? So I get 4H plus, add 4E, add 4OH minus. Tell me if you all see it. Then we go to the left now to form 2H2, add 2H2O, add O2, add 4E. Do you guys agree? That's how we add equations. This is nothing. You know, you do maths, you add equations, you add up everything on the left, add up everything on the right, you simplify. Isn't that what you do? Right. How many of you agree with this up to here? Lenise, you agree with this up to here? Leah, do you agree with this up to here? All right. Okay. How many of you see I have 4E on both sides, so it cancels? Who see that? Do you see that? All right. So 4H plus and 4OH minus is actually 4H2O. How many of you see that? Because our H plus and our OH minus is H2O. All agree? So if I have 4H plus and 4OH minus, that's 4 water. Do you guys understand me? They give me 2H2, add 2H2O, add O2. Right? So look again. If I have 4 water on this side and 2 water on this side, I'm carrying across that water there. So I get 2H2O. So I'll subtract when it come across to give me 2H2 gas, add O2 gas. How many of you understand that purple equation as overall? Right? If I use 4 electrons, this gives up 4 electrons. That has to take 4 electrons. It's all about redox and balance. So my electrons must be balanced first. How many of us okay now? You don't like it? Learn off the purple. Right? All right. Are we okay here? Could I take this off? Do you have it? So the reason is I did that. In conclusion, I'm saying this. Therefore, this is really, I've seen questions where they ask for that equation. It's really the decomposition of water. Right? When water is decomposed, we get oxygen and hydrogen. Right? So that is one way in which we could produce hydrogen gas if we wish. Is this okay? You all wrote that? All right. Next, head up for me. All right, so we're doing electrolysis of copper sulfate, and it could be dilute or concentrated. Aqueous CuSO4. So don't think that we have to tell you dilute or concentrated. Dilute or concentrated, you're gonna get the same thing, right? So let's draw this. And using inert electrodes, that means it's made up of graphite. Graphite, which will not interfere. All right, nice. So we have aqueous copper sulfate, negative, positive. This is my cathode, which is the negative terminal. Connected to the negative terminal, my anode, which is of course connected to the positive terminal. I'm sure you learned that out. And this is my aqueous copper sulfate. Right. Copper sulfate is what color? What color is a solution of copper sulfate? Answers in the chat. Blue. CuSO4 is blue. Right? Why is it blue? What makes it blue? Is it the copper or the sulfate? Because we have sulfate and sulfuric acid. So what makes it blue? The copper or the sulfate? Very good. Blue due to Cu2 plus. You can't be thinking the sulfate because then sulfuric acid would be blue. All right, good. So it's blue due to copper. Nice. Let's see what's going to happen here. Let me work out all of the ions present. So from copper sulfate, I will get copper ions. I will also get sulfate ions. Nice. From the water, I'll get H plus and OH minus. Great. Right. What ions will migrate towards the cathode? So the cathode, Cu2 plus and H plus will migrate. So both of them rushing towards the cathode, but only one will be preferentially discharged. Which one? Is copper lower than H plus in the series? Is copper very unstable? Yes or no? Tell me. Yes. Copper is very unstable and it's lower than hydrogen in the electrochemical series. So no matter how dilute we make this, there's a big difference in terms of the stability between copper and H plus. So it will always be copper. Is that clear? Do you guys agree? Cu2 plus will be discharged. And it will be discharged if it plenty or if it little bit. And the equation for that is Cu2 plus aqueous plus two electrodes to form Cu solid. Now this time we're getting a solid, right? So you will notice that around the cathode there'd be a pinkish deposit of copper. So the observation would be a pink brown layer on cathode. So the cathode suddenly start looking pinkish brown. Have you ever seen like a new 5-cent piece and it has that pinky brownish look? Y'all know what I'm talking about? All right. What is that pink brown layer? What is it? Will it be copper solid? You guys tell me. Will the cathode appear pinkish brown, guys? Oh. Right, so this is my cathode. And on the anode, I have sulfate versus hydroxide. Is sulfate ever discharged? Is sulfate ever discharged? OH minus is much lower and likely to be discharged. So you get 4 OH minus to form 2H2O, add O2, add 4E. Are you okay with the observations at the cathode and the anode? How many of us okay with this? So the observation here would be colorless bubbles. Ami, are you okay here with that? Denise, are you okay with this so far? Leah, are you okay with this? Sarah, are you okay here? So you get colorless bubbles and you appear with a pink cathode, right? Thanks for responding. All right, guys, are you fine here? Right, next order of business. Tell me what happens to the electrolyte. Let me see if y'all could work it out. They're gonna ask, what will you observe? What will you see happening to the electrolyte? Because you could see something here. Now, before you couldn't see, because you can't see if something getting more dilute or concentrated. But in this case, you can see something. Let's see. Could I take all of this out? But all right, if it getting more acidic, is that something you can see, guys? Let me ask you. You could see something becoming acidic? Be careful when they write observations. Observations is what you see with your eyes, right? Okay, so let's ask. If they ask what happens to the electrolyte, let's be careful with our words. What happens to the electrolyte? So I have Cu2 plus, SO42 minus, H plus, and OH minus. I'm removing this. That coming out. Nice. And so too is this. So it is becoming more acidic. I agree. Shanisha, you agree? You're saying that it's becoming more acidic. Yes?
Yes,
And
miss.
less blue. Can I say that too? Let me say it better. Less intensely blue. It becoming lighter. All agree? Why it becoming less blue, guys? Could you tell me why it's going to become faded or less blue in color? Because the CO2 plus is leaving. It has nothing to do with the sulfate. Right. So where's the observation here? You go right for them. if instead of they ask you this, they ask you it like this: observation to the electrolyte, what will you write? It becomes how? Less intensely blue. Is an observation that it becomes more acidic? I want you guys to tell me. Will the observation be that it becomes more acidic? Will you see that? You cannot see that, but you will see that it becomes less blue. Do you understand how the difference in which you answer the questions? Let me know. Okay. Copper sulfate is a blue colored solution which you would have all interacted with in chemistry, right? It's blue. So if we take it out, right, it's no longer there. This solution is going to become less intensely blue, or it appears faded. Is this okay? All right. Can I take out here now? Can we move on? Right. So do you understand copper sulfate with inert electrodes? Copper sulfate with inert electrodes. Are you good with it? Did the electrodes take part? Did the electrodes have anything to do with these reactions? No. Okay, good. Let's do, right? So it's all here for you, right? Becomes less blue, right? What happens to the electrolyte? It becomes less blue, but this one, only this one would be the observation, because you could tell this one. I can't see this not unless I measure it or test it with indicator, whatnot. All right. Now we are doing electrolysis of copper sulfate using copper electrodes. What does that mean now? That means copper sulfate with copper electrodes means that the electrodes are going to take part. The electrodes are active. Is this okay? Active. All good? Okay, take it down. I'll explain on the whiteboard after you have the note. Oh, all right, so electrolysis of copper sulfate. Let me get the whiteboard. Guys, sometimes I just know why it's better to make presentations something, because I just have to do back everything. Right, so electrolysis. I guess the presentations are so y'all of copper sulfate using copper electrodes. And this is important here. The electrodes are made up of the same metal that's in the electrolyte. So I know it's going to take part, right? So that means it's active. Both reactions will involve copper. Both reactions involve copper. And one have to be a reduction and one have to be a oxidation. So it's kind of really easy to remember if you think about it. If both of them have to be copper, one gonna increase taking electrons, one gonna give up electrons. Let's check it out. So this is gonna draw in case they ask me to draw. So I always practice in. Next thing I forget. All right, so here we go. So this is my CuSO4 there, negative, positive, copper electrodes, right? So I have, so these two are made up of copper. Okay, So cathode, it's not done normally, right? Cathode, Cu2 plus and H plus will migrate. Yeah, of course, they will still go, but H plus could never win. It will be copper because it's active anyhow. So this takes place because reduction, this principle holds that reduction must take place here, and it's involving copper. So the cathode becomes coated in a pink layer. Cathode becomes coated in pink. You'll see a pink layer. Right, there we go, if we were to draw it. Nice. Or I can say the cathode increase in mass because it gained more copper in mass by, say, X grams. It becomes X grams heavier. Okay. Let me see what happens at the anode. So at the anode, so both OH minus and SO42 minus will migrate. Both of them still want to go, but have nothing to do with these two of them. It will involve copper alone, but it'll be the reverse because the oxidation takes place now. So, Cu, the anode itself is going to be oxidizing to form Cu2 plus aqueous plus 2E. So it decreases in mass by X grams, must be the same amount. How many of you understand this? Do you agree with me? Hydroxide and sulfate still going towards the anode, but they're not going to be discharged. Both reactions must involve copper because this has active electrodes, they're going to be taking part in the reactions. And one is just the reverse of the other. If you think about it like that and you internalize that, you'll see really and truly you don't have much to remember here. Is this okay? Should it be by the same amount? If you notice it's not the same amount, it's probably because you weigh one too wet or something, right? But we'll talk about that when we see questions like that, right? They could ask you to think as to why it's probably not the same amount. And you could think maybe the student weighed it wet, right? And had extra water in there. That makes sense? Could they ask that? Is that a question to ask? That one increased by 2 grams, the other decreased by 1.8 grams. They could ask you that. And you have to come up with, being a person who does sources of error and whatnot, say something. Think of what could have happened during that experiment. Are you guys okay here? All right. Could I take off this? All right. Let me ask you now, what will be observed to the electrolyte? Yeah. So these are the two equations, cathode and the reverse of it, the exact reverse of it will be taking place at the anode. Right? This is aqueous. This is aqueous, solid. Right. What happens to the electrolyte? Will it become less blue, more blue, or same blue? More blue, less blue, or same blue? Look at it. I'm using up the Cu2 plus here, but I'm making it exactly back. Could you guys tell me if it would become more blue, same blue, or less blue? Very good. The electrolyte, write it down, remains same intensity of blue. Are you good with this? So electrolysis calculations. Let's see what happens here. All right. So far, we determined what products we formed. Right? We're going to determine now how much we're going to get. Right? Okay. Let's start with Faraday's law. Y'all know Faraday's law from physics? Yeah? Anybody? Okay. Faraday is a quantity of electricity. Right? Y'all did any electricity in physics? Charge? Do you know charge then? Q is equal to IT? Oh, then you know something. All right, good. Take this down for me. 1 Faraday is needed to deposit 1 mole of a singly charged species. So Faraday is a quantity of electricity. Well, a certain quantity that is for 1 mole of a singly charged species, right? Don't worry, you'll get it soon enough. Tell me when you have it. Do you think the more electricity we use, the more products we'd form? True or false? Is that logical to think that? That if we use more current or run the cell for a longer time, that we'd get more product? Yes or no? Yes, so of course we think that. That's only logical, right? Okay, so let's go. How much is a Faraday now? Think you'll know this now, since you did electricity. 1 Faraday is equal to 96,500 coulombs. All good? And charge is measured in coulombs, right? And charge, the amount of charge that is passed, is dependent on the amount of current that is passed in that circuit for, and, sorry, yeah, time. Sorry, guys, you all know I'm recovering. I don't know how long this recovery gonna be. All good? Tell me when you have here. Guys, did you need me to tell you that it's dependent on current and time? Or you could have think that? Were you thinking that the more current, the more electricity happening there? Yeah? All right, you did not really need that, right? Anyhow, let's do it. Okay, so 1 Faraday is equal to 96. Here, what I'll write here in case you can't understand there. Right. 1 Faraday is equal to 96,500 coulombs, right? Or 96,500 C is needed to discharge 1 mole of, and it's 1 mole of a singly charged ion. All right. So tell me now, to discharge this, if I'm using copper, okay, let me start with something easier. If I'm discharging sodium, which never comes out anyhow, how many Faradays are required here for sodium? There's one electron there. How many Faradays are required? 1 Faraday is needed. Do you guys agree? Because this is 1 mole of electrons to give 1 mole, 1 mole. All good? Do you understand 1 Faraday to discharge 1 mole of sodium? 1 mole of sodium. All good? Yes, y'all? Okay, what about copper? The equation is Cu2 plus add 2E to form Cu. How many Faradays are required for copper? 2 Faradays is needed. Tell me if I'm right. To discharge 1 mole of copper. Agreed? Because there's 2 electrons there. Yeah, y'all. Tell me if you're agreeing. What about aluminum? How many Faradays to discharge 1 mole of aluminum? Answers in the chat. How many Faradays will I require there to discharge 1 mole of aluminum? 3 Faradays will discharge. Very good. I need more electricity because I need 3 electrons there. Will discharge 1 mole of aluminum, right? What about oxygen? 4OH minus the form 2H2O, add O2, add 4E. How many Faradays to pass to give me 1 mole of oxygen? Yes, y'all? How many Faradays will I require to give me 1 mole of oxygen? 4 Faradays, 1 mole of O2. Look, 4 electrons, and this is a 1 there. Do you all see it? Yes. Can you tell me if you're fine here? Well, let me ask you something. How many Faradays will I be needing to discharge 2 moles of sodium? How many Faradays to discharge 2 moles of sodium now? Answers in the chat. To give me 2 moles of sodium, how many Faradays I'll need? That'll be 2 Faradays, right? You'll see how it works, right? Let me know if you're good. Can I move on from here then? Move on? All right, let me see where we're going with this. Right, so that's all here. Okay, so let me go through how to work a question. Okay, I'll write for you. I have some worked examples there, right? Okay, so to work out amount of substance discharge, write with me. Find the charge to discharge. Number 1, find the charge to discharge. 1 mole using Faraday's law. 2, then we will find the charge actually passed using Q is equal to IT, where I is a current in amperes, and T must be in seconds. Seconds, and seconds is S. 3. Find moles of substance actually discharged using 1 and 2, and 4, find mass or volume in question. So I'm going to check your question. Right, tell me when you're already here. I'll just write it. Okay, so find the mass. Here's how the question will go. Find the mass of copper deposited gosh. Find the mass of copper deposited in the electrolysis of aqueous CuSO4 using inert electrodes if 5 amps is passed for 1 hour. Okay, ready? Okay. How many of us ready here? Okay, so copper sulfate, the equation at the cathode will be Cu2 plus add 2E to give me Cu. Okay, so tell me now, how many Faradays will give me 1 mole of copper? Answers in the chat. Very good. 2 Faradays is equal to 1 mole of copper, or will produce 1 mole of copper. You all agree with me? This is 2 here. Therefore, 2 by 96,500 C will give me 1 mole of copper. 1 Faraday is equal to 96,500. You all okay here? How many of us agree with me? Or 193,000 C will produce 1 mole of copper. That is a quantity of electricity I need to get 1 mole of copper. All good? Right. Let me see how much we actually use now. Did we use a whole 193,000? Probably not. All right. That was the actual charge. Actually, Q is equal to IT, is the charge we used, which is how much? 5 amps for 1 hour. 1 hour is equal to how much seconds? 3600 seconds. You all agree? 60 minutes is 1 hour. 60 minutes is 1 hour. 1 minute is 60 seconds. All good? Right, so how much is the charge we actually passed? 18,000 C. Good? You all okay with that? Right. Now, how much we going to get actually? Think about it. 193,000 C will give me 1 mole of copper. So 18,000 will give me, let's see it, therefore 18,000 C will be 1 over 193,000 by 18,000. And I bring down the moles. Moles are copper, which is equal to how many moles? 193,000 is for 1 mole. So 18,000 will be 18,000 over 193,000 moles. Tell me here if that is correct. Who agrees? Right, how much we getting? Work it out. Use your calculator. Help me here. Right, so I'll leave it as 0.093 moles. But am I done? The question want moles of copper or mass of copper? What do we want? But could we easily convert moles to mass? The RAM of copper is 64. So what will be the mass of copper? Will it be 0.093 by 64? All right, I could take care of. Guys, could I take care of? Anybody still writing here? Say no. Nobody? Okay, so my mass of copper will be 0.093 by 64, which is what mass? What mass here? 5.952 grams or 5.95 grams. And I leave it like that. That's how much will come off. All good? Could you tell me if you are fine? We're doing this one. Find the volume of chlorine gases. Of chlorine gas formed at the anode. Right, how many Faradays to 1 mole of chlorine? Don't look at the answer. Yes, good guys. 2 Faradays will produce what? 1 mole of Cl2 gas. Do you guys agree? All right, well, work it out then. Work it out and let me know if you are getting this value for this amount of moles. Work it your way. And so 2 Faradays will give me 1 mole of chlorine. That means 2 Faradays will be 193,000 C will be used to produce a whole 1 mole of chlorine. Right, nice, I know that, fine. But did we use 193,000? I don't think so. We are going to check up how much we use by using Q by IT. Q is 10 amps. I don't need to do anything there. 1 hour, you know now, 1 hour is 3,600 seconds. That is 36,000 C. All good? So I'll write 193,000 C will give 1 mole of chlorine, right? So therefore, 36,000 C will be 1 over 193,000, right? By 36,000. And moles will be coming down on this side. Moles. So I'm getting how many moles? Are you getting 0.186 moles? Am I right there? So checked it over on your calculator. Did you guys check it up? Right. But this question, we want mass or we want volume of the chlorine? What do we want? We want the volume of the chlorine. So you have to multiply it by 24. Because you know, 1 mole of a gas occupies 24 dm cube. So 0.186 moles will be 0.186 by 24 dm cubes. And are you getting about 4.48 dm cubes? Yes? How many of you okay here with this calculation? You're good, right? Okay, you're doing 1 more for me. Then I will be satisfied with it. Hopefully. Right. Tell me now, do this one. What volume of gas, I'll just leave it up to you to figure out what gas that would be, at RTP, you can start in the chat by telling me what gas that would be. It's formed in the electrolysis of dilute or concentrated H2SO4. Tell me what gas I'm talking about in the chat. At the anode, I should have tell you that first. If 10 amps is passed for 2 hours now. Go ahead here. Start off by telling me what gas we're talking about in the chat. So at the anode, this is what will happen. Remind me, how many Faradays? 4 Faradays will give me 1 mole of O2. How many of you said that? Or alluding to that? Right, this is 4 here, and this is 1 there, right? Okay, work it out then. So 4 by 96,500 C will give me 1 mole of O2. How much is that? It's 384 or something. 386, I meant. You keep going, you'll get it, right? Especially like those Form 6 labs appearing, they just not put in statements. So please make sure whenever you are answering questions, you put the correct statements. So Q, so 4 Faradays will give me 1 mole of oxygen. How do I know that? There's 4 electrons here. Look at it. To 1, and this is 1. 1 is understood in front of the oxygen. So that'd be 4 Faradays being required, right? So 10 by 2 by 3600 will give me the amount of Faradays charge. That'd be 72,000 C. Am I correct? Is that right? Nice. So I'll write back for them so that examiner will see that I know what I'm talking about. So even if I make a mistake, they could give me marks. 386,000 C is equal to 1 mole of O2, C moles on this side, right? So therefore, 72,000 C will be 1 over 386,000 by 72,000 C, right, will be the moles of O2. My moles of O2 is how much? 0.1, how much? 87. Yes, that's what. 0.187 moles. So if I get up to here, I would have gotten most of my marks. So make sure you get up to there safely. But the question doesn't want mass, we want volume. And you know volume of a gas is equal to moles, and this is RTP. The RTP constant is 24. 24 dm cubes is 1 mole. Moles by 24, which is 0.187 by 24, which is how much dm cube? Was that the 4.48 dm cube? Roughly? Yeah, roughly 4.48 dm cubes. How many of us are okay with these questions?